Alright, so this is the MixNumber inherits fraction problem. Basically what we want to be able to do is have a class, let's call it X, have an object of the class, and we can pass it 3 values, and then be able to display it as a mixed number. So this is the whole number, this is the numerator, and this is the denominator. We're going to use 2 classes to do that. The mixed number, which will inherit the fraction class. We've already been given the fraction class, but let's take a look at it. The fraction class has the numerator and the denominator. It has a constructor. This constructor takes a numerator and denominator. So there's 2 ways we could construct it. We could say fraction, we're just going to call it X, new fraction. So we could pass it values, or we could not pass it values. This will give it 2 and 3, as we define. Whatever we pass it equals the num, and whatever we pass it equals the denominator. Or if we don't, it's going to set it equal to 0 and 1. So this was overrode the first call. And this is the toString method, is what happens. Defining it specifically toString, that method is special in Java because it defines what happens when you try to print just the name of the object. In Python is the same as saying print X, but it's important because it tells you what just X means by itself. Or if you're not in the line code, if you did system.out print X. And it's defined here as return num/den, which is what we want. Is basically to display the thing as a fraction. But we could change this inside string part to a bunch of gibberish and compile and run it, and it would do the same thing. What is it? Fraction X equals new fraction. If we print it, basically, if we just call it to print, the toString method is understood here. It calls x.toString without having to say it. So it's an important method, but it's right. It's been given to us. It prints the fraction part of it. And we have get and set methods, which are staple methods. x.get num, x.get num, x.get den. We can set the num. So this allows us to change it after we've declared it X, or let's just print it X. So I haven't recompiled it since I changed it back, so it was all the gibberish from before. Those are the get and set methods. All of these are going to be inherited. We're going to pass them along, and these are irrelevant. These are just test things. Comment them out, but we're going to run the main method is going to be run in, well, it could be run here, but we'll run it in our MixNumber class. The MixNumber extends fraction, so it inherits the values of fraction and the methods of fraction. So it inherits the numerator and the denominator. The only thing left for it to provide is the whole number part. This is going to be a constructor. The constructor, we need to pass it the 3 values, the numerator, the denominator, and the whole number. And I think I said it backwards when I showed it. If it's 3, 4, 5, this would be the whole number, I guess. So this would be 5 and 3/4. But we could change the order if we wanted to. We won't, but could do int whole instead. Super is is pretty awesome. Super allows you to refer to the above class. So super open is going to call the constructor. Now, we're going to call the constructor and pass along these two values. So that refers back to whatever this is, fraction. Now, there is a constructor class that takes two values. So it's going to run through this. It's going to set the numerator equal to the num and the denominator equal to the denominator. We could just as well call just the super, and that would set it equal to this would run this class, so it would set the numerator equal to 0 and the denominator equal to 1. But we don't want to do that because we are passing it. We are passing it in numerator and denominator. Is that the right order? Num, den? Yes. And the other thing we want to do, the only thing that isn't dealt with in the constructor, in the super class, is this here. So we want to set this dot whole equal to whole, the number here. Now let's deal with if we the default constructor, if we pass it no values, what do we want it to equal? Well, we can just call the super to set the numerator equal to 0 and the denominator equal to 1, and we can set the whole equal to whatever we want, but it probably makes sense to do 0 for the whole number. So that's where we would start if we constructed it without passing it any values. Now we have inherited, we've extended the fraction methods for getNum, setNum, getDen, setDen. However, we don't have get and set methods for this whole here, so we might as well set and get methods. To set, we don't return any value, so it's void. Set whole, int whatever we pass it, we'll call it whole. This dot whole equals whole. So this value equal is sent to this value. So it's taken from outside the class and put into that value. And for the get, it's an int, so it's going to return an int get whole, and it's passed no value because all we want is to get it. Return this dot whole, so it returns that value up there. Okay, now we want to override the toString method because we don't want it to just show a fraction. The toString method. Where are you? We don't want it to just show a fraction. We want it to show the whole number plus the fraction. So it's returning the string. The method is called toString. We're passing it no value. And we're returning the whole number, this dot whole, plus a space plus a fraction. Now the fraction we can define as num plus slash plus den, and that will work. But for fun, let's call the super method. The super method, we can call the methods, any method from above, we can call it from below with super dot. So super dot toString will call the above methods toString, which is cool. The values would be the same, but it will resolve it. It will toString it with that. So instead of constructing it all, we can actually refer to a higher two-string method. Now there's a bunch of a couple examples here, but we can run it in the command line. So let's compile and run it and see if it works. Compiled, that's good news. So we have stuff run from here, but let's do it one by one. It's MixNumber, right? MixNumber, we'll call it x equals MixNumber. Let's pass it no value. It didn't work. Oh, I didn't put a new MixNumber. X equals new MixNumber. Alright, so it's there. Let's print it. The X is inherently the two-string method, so it should show the default, which is 0 and 0, 1. Let's try MixNumber y equals new MixNumber, and let's pass it values. And again, the order that we have is here in the constructor, so it's numerator, denominator, whole, as it stands. So I don't know, 5, 6, 2. That should give us 2 and 5/6. So let's see. Y, 2 and 5/6. Hot dang. Alright, so we have the set method, the set whole, which enables us to set whole some other number. Let's change it to 1. And let's print it again. That changed the 1. We could do y.getWhole. Oops, y.getWhole. And that would give us that whole number back. That's the method we define. But it also, even though this is a mixed number, it stole all the fraction stuff. So we can do getNum, and that will give us a value. We can do setNum, change it to 123, and then print it again and see that the fraction part's up top here. So it seems this is everything. If you have any questions, let me know.